It's just going to be a short video today about some basic stoichiometry concepts. One of them is the mole, the infamous mole. The next one is something called Avogadro's number. And the last thing is called and the last thing is called are the different ratios that we can do using these. So we're gonna call ratios. So first, the mole. So we talk about a dozen being 12 of something. So if we have a dozen eggs, that means we have 12 eggs. So 4, 5, 6, 7, 8, 9, 10, 11, 12 is a dozen eggs. Or we might have a dozen arrows. We might have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arrows. So we can have a dozen eggs, we can have a dozen arrows, a dozen footballs, things like that. When we talk about the mole, a mole is essentially a dozen in chemistry. We say we have a mole of things. You have a mole of hydrogen, a mole of oxygen. It's essentially like our dozen. So that brings us right into Avogadro's number. There was a man by the name of Avagadro who did some counting of atoms and decided that there should be 6.02 times 10 to the power of 23 atoms in 1 mole. So essentially, when you have if you want to have a mole of oxygen, you just need 6.02 times 10 to the 23rd molecules of oxygen. This is actually atoms or molecules. So that's Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules in 1 mole. So 1 mole of silicone is that many atoms of silicone. Something else that's interesting is 1 mole is also equal to the molar mass of the element. So if I have 1 mole of for example oxygen, that means I have 15.999 grams of oxygen. If I have 1 mole of oxygen, 15.999 grams of oxygen. However, if I for example had 1 mole of H2O, that's water, then that is actually the combined molar mass of 2 hydrogen and 1 oxygen. And so 2 hydrogen are 2.016 plus 1 oxygen is approximately 16. We're just going to round it out. That makes it 18.016 grams of water. So if you get that many grams of water, you can successfully say I have a mole of water. So essentially, we have multiple ratios that we can do this for. We can compare moles to moles. We can say that X moles of X2O and Y moles of X2. So we can compare moles to moles. We'll see those later when we talk about chemical equations. We can also have grams to moles, grams of element X to moles of X. And essentially what that is 1 mole, and then this is the molar mass up here. We can also have X atoms of X in, we don't need the X here, we know what that is. We know that that's 6.02 times 10 power 23 atoms of X in 1 mole of X. We also know that when we take we could say that is 6.02 times 10 to the 23rd atoms of X in 1 mole of X. So these are all kinds of ratios, and we'll see those later when we talk about stoichiometry concepts, when we talk about chemical equations and balancing those chemical equations and such like that. So these are some very important ratios to make a note of, because we will definitely be seeing these later.